In this video, we're going to take a look at applications to mechanics. So 3D vectors can be used to solve mechanics problems in the same ways we did for 2D vectors. So what we're doing is we're taking the first year material that we covered for mechanics that was involving vectors, and we're now just extending that to 3D space. So other than that, there's nothing really more to say here. So let's take a look at some practice questions now. So for question 1 here, we've got an object that's acted upon by 3 forces, F1, F2 and F3. So for part A here, we're asked to find the resultant force acting upon the object. Remember, for a resultant force here, that's the sum of the individual forces. If I call the resultant force R is equal to F1 plus F2 plus F3. Let's write that down here. So, to add these 3 forces together, it's up to you whether you write these as column vectors, or whether you just sum the I components, sum the J components, and then finally sum the K components here. What I'm going to do is I'm just going to add here to get the resultant force by just summing the components here. Okay. So for the I component here, that's going to be I plus 4i, so that's 5i, minus I, so that's going to give me 4i there. For the J component, that's going to be minus 2j plus j. That's going to be minus j plus 4j, so that's going to give me plus 3j there. And then finally for the K component, we've got 3k minus k, so that's 2k plus k would give me plus 3k. Okay, obviously don't forget this is a force here, the resultant force, so we need our units here of newtons. And like you can see, it's as easy as that for part A. Now for part B, it says find the magnitude of the resultant force acting upon the object. So we're looking for the magnitude of R here. Now remember, for the magnitude of the resultant force here in this case, we just need to apply Pythagoras. That's going to be the square root of 4 squared plus 3 squared plus 3 squared again. So what I'm going to get here then is the square root. I'm going to get 16 plus 9 again. In that case then, add 16, 9 and 9 together. What we're going to get is the square root of 34. So it doesn't ask for it in exact form, but it doesn't ask for it to a degree of accuracy here. So it's somewhat arbitrary. So you could leave it like this. Obviously, we're looking for the magnitude here, so that would be newtons. So root 34 newtons. Or I could write this then as 5.83 newtons. Okay. Either of those there would be absolutely fine. Okay. And there we have it. So like you can see, quite straightforward. That gives us the solution there to question 1. If we just take a look at one more question here to finish with, we've got a particle of mass 6 kilograms, which is acted upon by the force 12, 6, minus 3 newtons. Now we're given that the particle is moving with constant velocity. So for part A here, to find the acceleration of the particle, we need to use Newton's second law. So F is equal to mass times acceleration. So we know the force, that's here. We also know the mass. So in that case, we've got everything we need here to actually answer part A already. So I'm going to get 12i plus 6j minus 3k is equal to the mass here, which is 6, times the acceleration. So that's going to be 6a. Obviously, if I want a here, if I just want a, I just need to divide through now by 6. So I'm going to get 12i plus 6j minus 3k. It'll all be over 6. So in that case then, if we simplify here, 12i over 6 would give me 2i. 6j over 6 would give me j. And then finally, minus 3k over 6, that would give me minus a half k. Okay. So because we're talking about the acceleration here, don't forget the units, this would be meters per second there. Okay. That's our solution to part A. Part B then, to find the exact magnitude of the acceleration of the particle, we need to use Pythagoras. Going to be the square root here of 2 squared plus 1 squared, and finally plus minus a half squared. So minus a half squared. So if we just evaluate this here, we're going to get the square root of 4 plus 1 over 4. And again, if we just keep simplifying here, it's going to be the square root of 5 plus 1 over 4. So what I can do now is write this as 20 over 4 plus 1 over 4. It would be the square root of 21 over 4. Obviously, don't forget the square root of 21 over 4. I can write that as the square root of 21 over the square root of 4. That's going to give me the square root of 21 over 2 there. Okay. So because we're looking at acceleration here, this would be meters per second there. Okay. And there we have it. So that's our solution to question 2. And that brings the end of this video on applications to mechanics. In the next video, we're going to take a look at exam revision for 3D vectors.